And I was fortunate enough to meet Yuri Stepanovich Rybnikov, and he ran a comb through my hair, and just like that, there was a charge. Electric current turned out to be a byproduct. No one has ever seen an electron. Powdered particles, they restore their charge. All substances are made up of electric charges.
Hello, dear viewers. We welcome you again to our podcast. We are continuing our series, and my name is still Alexander Salvatov, but today we have a new guest. This is Viktor Tiunov, the founder of the ElectroAtom project. But I think now it will be much more interesting and eventful. He will introduce himself. Viktor, thank you very much for coming. Thank you for giving us your time. Please share with our viewers. Tell us in more detail who you are, what you do, and what deeper connection you have to the ElectroAtom project.
Yes, Alexander, it's true that lately I've quite frequently and consistently been asked to talk about myself and my experiences, and I always find myself wanting to approach this topic a little bit differently each and every time I speak, so that the presentation doesn't sound exactly the same or become repetitive for the audience. And I am the founder of the ElectroAtom project. We'll talk more about what this project is later on. Yes, but let me talk about myself. Honestly, I don't even know where to start. But maybe I should start from my early childhood, so to speak. Yes, because in reality, this project and I are essentially one and the same, since it began back in my distant childhood. Now I'm already 41 years old, you could say. And this project started, at least for me, when I was about 0.7 years old. Yes, why is that exactly? I will explain. My father, even though I personally do not possess a technical education myself, was an incredibly gifted inventor. Truly, he was honestly a genius. He had all sorts of gadgets, all kinds of things. I was just curious about what he was doing there, how it all worked. I was always drawn to it, and from time to time he would let me join in. He would pick me up under my arms, sit me on his lap and say, "Here, let's solder this to that, attach this here," and so on. So basically, ever since I was little, from those early years, I really liked it, and I developed this sort of inventiveness. You create things? Yes, to create something new, inventive. This kind of initiative appeared in me. But then, as time progressed, life truly went on, and there was a particular period in our country's history. You know, those memorable 90s, when brilliant and innovative inventors simply weren't of significant interest or much importance to anyone at all. So you had to make money, right? And of course, everyone clearly saw that the main and most promising way to earn money was if you went to diligently study economics, or perhaps even law. Economists, lawyers, I remember back then it was quite a prevalent trend, a significant fashion, yes, a truly fashionable trend. Naturally, it affected me too, so I was sent to study here in Tomsk, of course, at the esteemed Faculty of Economics. So I enrolled and diligently studied economics, but I always had this strong pull toward something else, toward innovation, some kind of groundbreaking invention, yes, to create something truly novel. That was always much more interesting to me than all these economic matters. But in principle, economics, now this comprehensive economic education, actually helps me immensely. And I was incredibly lucky enough to meet the distinguished Yuri Stepanovich Rybnikov, who is a world-renowned professor both in Moscow and at the Institute. He worked extensively on friction, as I already mentioned, and friction is a fundamental and ubiquitous process. When we first met, we started communicating, and together we successfully organized a joint company that dealt with effectively eliminating wear in friction units. In fact, that's still precisely what we do now, if anyone is interested, solving complex problems in friction units. Our company was called the Scientific and Technical Center Tribel2 because Yuri Stepanovich Rybnikov originally had his own company. He was the sole owner, and it was called Tribel. And what is Tribel? It's from the word triboelectricity, which again is fundamentally about friction. Yes.
Yes, that is absolutely correct, and that's precisely right, indeed.
So that's why our company was called Tribel2, because Yuri Stepanovich Rybnikov thought that since there was already Tribel, you couldn't call it the same, so we named it Tribel2. It's just little details, nuances, but why 2? Well, that's just how it was. Because yes, there was already one. So, and basically it was on the fundamental basis of this particular company that I truly started my comprehensive learning journey. Rybnikov, a truly remarkable individual, meticulously passed all his extensive knowledge and profound insights on to me. He would frequently come here to Omsk, making the considerable journey, and he specifically brought me his innovative tribo generator, a device of great significance. And from that precise moment, we enthusiastically started working on what we now universally call a power station. Yes, this is indeed the very model in this specific case. So, Rybnikov Yuri Stepanovich, a brilliant and insightful inventor, personally brought me his tribo generator, which he had made completely by a fortunate accident, as often serendipitously happens in the realm of scientific discovery. This remarkable event occurred still during the challenging Soviet times, within the vast expanse of the Soviet Union, and back then, the revolutionary process of powder coating was just beginning to become widely common and increasingly popular. Yes, it was truly a new and groundbreaking kind of technological advancement. And in order to effectively charge the powder so it would reliably stick to the part with optimal adhesion, there were these absolutely huge, incredibly large machines that were specifically designed to generate extremely high voltage, so our esteemed viewers don't get too stressed or overly concerned, yes? So, one memorable morning, Yuri Stepanovich, after his usual routine, woke up, meticulously washed his hair, and then ran a simple comb through it, and suddenly, to his utter astonishment, there was a significant electrical charge. It got powerfully electrified, and he immediately thought, with great clarity, why do we truly need these enormous, cumbersome machines that are potentially harmful, that generate such dangerously high voltage, and create a complex field through which the tiny powder particles meticulously fly, picking up a crucial charge, and then they are powerfully attracted to the grounded part with precision? He thoughtfully considered, why do we genuinely need all these potentially harmful and overly complicated things if we can achieve the exact same highly effective result with a simple, elegant movement and a much more straightforward approach?
Everything becomes more accessible, simpler, without such complications.
Then he thought, what if I could make this particular kind of device that would effectively charge the powder? And that's precisely it. And he remarkably managed to do it, even though there were many opponents who clearly said, come on, Rybnikov, the Japanese can't even do it, and you truly think you can? Where exactly are you going, you utter fool? What are you even trying to accomplish? But in the end, he ultimately succeeded. He patented this innovative device for applying powder coating, his very own triboelectric device, in a total of 5 countries. By the way, Japan was prominently among them. I don't remember with absolute certainty exactly which countries, but it's readily available on our website, so if anyone is genuinely interested, they can easily go and check it out. I remember for sure that Japan is indeed on the list, because people consistently kept telling him about the Japanese, and he made it a significant point.
Yes.
He made absolutely sure to meticulously patent it there, yes, and actually, that very first groundbreaking triboelectric generator he painstakingly built, he personally brought it directly to me. So now, I am the proud owner of this truly legendary and historically significant device, a remarkable piece of scientific innovation.
Could you call it an exhibit?
Yes, you could certainly call it an exhibit, but actually, it truly works much better than all the other existing devices. And the crucial thing is, the primary and most significant feature of this particular triboelectric generator, actually, to be more precise, it's a specialized triboelectric charging device specifically designed for powder coating applications. That's its official designation. The absolutely key point was this: if you do not effectively divert the substantial electric current that is generated when numerous powder particles pass through the main body of the triboelectric generator, you will undoubtedly receive a significant electric shock, potentially up to 200 milliamps. For an average person, that level of current is already quite noticeably uncomfortable, and the associated voltage is just absolutely insane. Like, you would observe this truly huge and powerful arc if you fail to divert it properly. It's kind of like experiencing a stun gun, so to speak, a very unpleasant sensation. If you do not effectively divert the electric current, you will indeed get shocked. So, the fundamental key was that this electric current, surprisingly, turned out to be a valuable byproduct, which we can efficiently collect and then transport anywhere on this entire planet, or perhaps even much further into space.
It's very reminiscent of the story where an apple fell on Newton's head and he discovered the law just by chance, one discovery leading to another.
So that's precisely how it was. And then Yuri Stepanovich thoughtfully considered, why couldn't he, in fact, construct a generator? This particular sample he brought to me, his remarkable triboelectric generator, you could quite accurately and truly call it that, a triboelectric generator indeed. The only thing left was to make it industrial, to create an industrial version, that's all. And to find a way, not even a way, but rather to understand the second component of this power plant, that the powder particles restore their charge. Yes, and he measured that as well. So the essence is very simple. When a powder particle flies through the body of the tribo generator, and what I'm about to say, he later proved experimentally. We get an electric charge, and he proved experimentally that the charge comes specifically from the material, from the powder particle itself.
In other words, it is not created out of nothing. It is extracted from the particle. Yes, it is extracted.
So you can't get something from nothing. You can't just take some kind of free energy that simply doesn't exist. It's just elementary. If you take something, you take it from somewhere, from something. Nothing comes from emptiness. So the electric charge is taken specifically from the particle. And right now we're not going to discuss what kind it is. Everyone says it's a static charge and so on. By the way, since we're on the topic now, the charge is not static. Why? Because we are removing it. And that's already dynamics. There's no arguing with that. And all of this is recorded, by the way, with instruments. So a powder particle has passed through. And by the way, why do we take the charge from a powder particle? Here's the research. Take Rybnikov, for example. He wasn't the only one conducting it either. He and his colleagues did it together at Maria. So why do we take the charge specifically from the particle? Because there's this device called the Paul triograph. It's a device like that, a fascinating apparatus. And if we meticulously take a powder particle that we've carefully run through, that is to say thoroughly rubbed, so to speak, creating friction, and then compare it with a powder particle that we haven't rubbed at all, then the powder particle that we've indeed rubbed exhibits a significantly lower ignition temperature, meaning it consequently requires much less energy or heat to ignite and begin combustion. And when you subsequently run it through the tribogenerator once again, it consistently produces a noticeably higher electrical current. That's the particle. This is what the Paul tree photograph records. But if it's a particle that hasn't been run through, hasn't been rubbed, then it needs a higher temperature to ignite and produces less current on the first run. So in a way, Cosfin conditionally proves that we're getting electricity specifically from the powder particle. That is, when we extract the charge from the particle, we destroy it. This is called wear. This is called wear. This is called wear. So we've kind of worn out this powder particle, and it flies out with an insufficient charge, passes through, and settles on the grounded part. Why? Because when at that moment, if it's specifically a powder particle, then the charge flows to it from the ground.
And it gets replenished. And it
sticks because of this, so to speak. It gets magnetized, so to say. Well, like we used to do in physics class. I don't know if they still do this now, but we used to. You take a stick, rub it on your hair, and suddenly the paper bits stick to it. But there are no magnetic materials there. None of the paper bits are magnetic. And the stick, even if it's ebonite, it's not a magnetic material either. But nevertheless, they stick together. It's kind of like magic, but in reality, it's a property of electric charge. To attract, repel, and rotate. That's what electric charge does. And that's why it sticks to the grounded part. And at that moment, when it sticks due to adhesion with powder particles, current flows from the ground. This is easy to detect. That is, a particle with an insufficient charge starts to replenish it. In other words, charges from the ground move into place, into the powder particle. It's as if it gets recharged. After all, we depleted it.
We could say, roughly speaking, that it's like when we plug a device into an outlet to charge it, hear this outlet. So,
hear this outlet? Yes, it's also the planet.
Our planet is a huge outlet, dear friends.
It's like an apple. We took a bite out of the apple here, and then it went to the consumer. And essentially, it's also in the field. Any device that acts as a consumer, a light bulb, anything at all. In any case, it all goes back into the Earth. It all returns to the planet's field.
A cycle.
Yes. That's why our planet is alive. Because there is a constant exchange of charges. That's what it's called.
I'm starting to notice that our podcast is becoming not only useful for those interested in the ElectroAtom project, but it could also be helpful for kids who are simply curious about some scientific aspects. Some people love physics, and right now they're learning a lot about electricity, about charges, about how, for example, even sand can be charged, and that the Earth, our planet, is a giant socket. Very interesting terms. It'll be fascinating.
Yes, that's a very general way to put it. Something like that. And that's why the powder particles are restored, but they're not fully restored. According to measurements, they recover up to 85%, and we send them off. We can collect these powder particles and send them again for electricity generation to extract charge from them, then restore them again. As
you said that after the very first run, the electricity is extracted, but after the complete restoration, the electricity is extracted much more efficiently. And why is that the case?
Why is it more efficient? Because this powder particle is 20 microns in size. And the smaller the particle, the easier it is to extract charge from it. Why? Because it tends toward atomic size, according to our theory. I think Rybnikov himself didn't deal with theories. Everything consists of electric charges. How did he prove this? He would take all substances and run them through his tribogenerator, and we only know 3 types. These are conductors, semiconductors, and dielectrics. And he used powders. For example, he would run metallic powder through his tribogenerator. He had a fluoroplastic tribogenerator. He would run metallic powder through it, and they even made a metallic tribogenerator specifically for testing.
Experimentally?
Of course. Moreover, there are even formulas derived for this, formulas for current generation, for powders, for larger pieces. Everything is there.
You could make a textbook out of it right now.
Everything is proven. All of it works and all of it has been verified. The beauty of Rybnikov Yuri Stepanovich's work is that anyone can verify it. For example, we can't exactly go and check the Large Hadron Collider ourselves. It's complicated. They're trying to obtain the particle that gives matter its mass. That's what they're trying to do there. Basically, they're trying to get the densest particle possible. But how can you get a dense particle in a vacuum if it keeps compressing everything? And they're doing this by colliding electric charges. They're pumping in electricity. They get an explosion which also compresses everything. So how do they expect to get it? Well, that's a whole separate story. Basically, we can't verify it ourselves. All they can do is tell us we discovered a particle. Some kind of ultralight particle. Its lifespan is like 0.0002 seconds. It has certain properties. And it's called something like newtonium, for example. So what exactly did you discover? A name?
The particle no value. It's just...
The name. Yeah, so its lifespan is this much. And somehow they even managed to determine its properties. How they do that, I have no idea.
Maybe I'll apply this knowledge somewhere.
In some very specific and particular geographical area. Its overall lifespan is such and such, and it typically thrives in these conditions. Its properties are undefined. The particle is called such and such. Something like that. We can't verify this, but with Rybnikov you can just take it and check it yourself. All the instruments are available. They're sold in stores. Go ahead, take them and do it. Basically, he tested conductors, semiconductors, and dielectrics. And throughout all this, when he ran all these powders through his tribogenerator, well, powders like, say, aluminum powder, or for example, powder with a semiconductor. Everyone knows graphite. Yes, everyone knows that's carbon. We take carbon powder and run it through the tribogenerator. So in all these cases, he always got just one thing. It was a direct electric current. And on a graph, a direct electric current is a straight line. That is, if we plot it on a graph, it's a straight line. That is, there is no negative component there, the one Benjamin Franklin came up with. I don't remember if it was in the 1800s or 1700s. The pluses and minuses, those ones. The ones everyone relies on now, so to speak. He came up with them just for simplicity. To make it easier to explain, to express the idea, well, that's it. And basically, from all these simple ways of expressing ideas, that's how the theory of electricity came about, right? The one with the negative sign.
Yeah.
And in direct current, that means there are no electrons. There's no negative component there. Where did it go? That's exactly the point, the electron. What's the deal with it anyway? The thing is, no one has ever actually seen an electron. Never. And it was born at the tip of a pen. That's all. And the Academy of Sciences knows this. And there's a Nobel laureate, Joris Alferov. Maybe you've heard of him. And at some point he met with students. And the students asked him this question. There's even a transcript. Is there such a thing as an electron? And he told them, to be honest, no one has ever seen an electron. And there was this scientist, Röntgen, who actually forbade the use of the term electron in his laboratory. Because no one has ever seen it, and we shouldn't operate with made-up concepts. We should only deal with what we can demonstrate and prove experimentally. only what we can show experimentally.
Dear friends, you can write in the comments under this video what you think. Does the electron exist? What scientific works have you come across? And maybe you know some scientific terms. It would be interesting to hear. Of course, science is always fundamentally about gathering comprehensive information. The more knowledge we collectively acquire and share together, the better for everyone. Perhaps in the comments section below, there will be someone who can genuinely share and definitively prove something entirely new, not merely with abstract scientific arguments, but rather with concrete actual material evidence, thereby explaining and truly revealing something novel and significant, just as the renowned Rubnikov once remarkably did in his time.
We'll be waiting, as they say, with anticipation. And so, physicists want to create a unified field theory, you may have heard of it, which they haven't been able to do for 200 or even 300 years. They just can't come up with this theory. Why is that? Because they have positive and negative charges, and when a positive and a negative meet, annihilation occurs, so-called annihilation, meaning destruction. So how do you expect to create a unified field theory if you have fundamentally different particles, so-called charges, to begin with? But if you take as a basis, as experiments have consistently shown and demonstrated over time, that charge is actually electron neutral, then the field theory arises automatically as a direct consequence of this fundamental property. Exactly. So, Yuri Stepanovich Rubnikov not only possesses profound mathematical insights, but as an accomplished physicist, he actually combined the intricate fields of physics, the elegant discipline of mathematics, the complex science of chemistry, and even the nuanced study of native language, all into a single, cohesive, and truly unified body of comprehensive knowledge. Essentially, this is a truly unified body of knowledge which, as he explicitly stated, was deliberately and intentionally divided in order to effectively control and maintain power over the populace.
In some way. Well,
basically, to make it easier to control people. He also has a periodic table. We know the Mendeleev periodic table, which in fact is not actually periodic because it lacks the element of periodicity. Very few people think about this and they don't tell us about it in school. Yes. But there is no element of periodicity in it, so in reality it's not actually periodic. And this periodic table that they show us in school is actually distorted. In reality, Dmitry Ivanovich Mendeleev actually had a slightly different table, and the Academy of Sciences knows about it. And this table is in the Mendeleev Museum in St. Petersburg. If anyone is interested, you can visit the Polytechnic Museum, where there is a small section dedicated to Dmitry Ivanovich Mendeleev, and his table is there. And in this table, there is a 0 row and a 0 period. And this hydrogen, which is currently placed first, if you look at the table now, hydrogen is in the first position.
For
Mendeleev, it was only third, because there were also X and Y. There was a 0 row and a 0 period, and X was placed there, because Mendeleev understood that there had to be a particle from which everything is made.
Everything started from something, the very first thing, and
it was counted from 0. This is important, very important.
As far as I know, the commonly accepted, widely known version of the Mendeleev table used in school curricula was intentionally and specifically designed that way for ease of understanding. But there are also many theories suggesting that there are different versions. I've seen a circular version of Mendeleev's table with its own schemes, different approaches.
Unfortunately, this lack of knowledge about patents, in fact, this is a violation of Mendeleev's copyright. Because his version was actually patented. And, well, he's no longer here. And there's no one left to worry about it. So now you can make a triangular one, or any other kind you want, and no one will stop you. And why is that? Because it can't be mathematized. So why try to change it? Because it can't be mathematized by the great science of mathematics. Mathematics can do everything. Absolutely everything. It can calculate anything at all, but it can't handle Mendeleev's table.
So, does that truly mean that if the profound and intricate field of mathematics could somehow, in a universally accepted and undeniable manner, provide the fundamental and underlying structure,
then
it would have remained fixed?
You wouldn't have been able to change it in any way. I mean, you couldn't make it a square or a circle. Mathematize it, of course. Because there are no elements of periodicity. That's why. And why aren't there any? They were removed. There used to be X and Y. They were taken out. There you go, that one is mathematical. Zelensky
Conspiracy?
Zelensky conspiracy. Call it whatever you want. They came up with this mass number, carbon units. Because even now the atom, no one has even separated one from another. And no one has said how to weigh it either. But they say it's by mass. They arranged Mendeleev's particles. They arranged it by mass. In general, this is where Rybnikov comes in. By the way, he also had to check all of this, and he thought, well, somehow none of this adds up. If we look at this table under normal conditions, it says there that the elements are arranged in increasing order. We're told that oxygen is divalent in all compounds, but it's placed in the 6th valence row. Why? Well, you could start saying something about it. There's a lot of talk, a lot of discussion. So that's how it is. But if you, let's say, ask them to define it, they won't be able to. So there are even more questions there. That is, they answer this question for you, but then, yes, you have a lot more questions. And they're all theoretical, and there's no way to verify them. Well, it's simply impossible. It's as if it's just made up. In fact, that's exactly how it is. If a chemist sits down and tries to explain to themselves why oxygen is divalent, but is placed in the 6th valence row, they won't be able to. But honestly, if they do it not for money, but sincerely,
I'll write that down as my homework. I have friends who are chemists. I should ask
them, yes. And when you ask them, you'll end up with more questions than answers. That's actually how it is. And then I'll tell you the answer now, and you can suggest this option to them later. Like Rybnikov did. He arranged the periodic table according to the only parameter that exists in nature, which we can measure, its density. Yes. And he arranged the elements by density. And the entire table was flipped completely upside down. And oxygen ended up in the 2nd valence row, which is a significant position.
as
Strange as it may seem. If we arrange the elements by density, again, Yuri Stepanovich himself undertook this task before the publication of the book by J, a significant work that he completed personally. Slee came out called Elements. That's it. There's a scientist in the USA, J. Slee. And he published a book called Elements. And in this significant book, he thoughtfully suggested arranging the various chemical elements by their respective densities. And when he made this suggestion, Rybnikov had already done it before, and he was just waiting. He needed something to lean on, something to say. It wasn't me who suggested it. Whose idea was it?
did it.
Well, he suggested it, and I actually did it. And so, look, this is how it turned out for me. That's how this table became periodic. Yes, it became periodic according to 5 parameters. It became mathematized.
Immediately.
Automatically. It became mathematized. All the elements, if they're semiconductors, they all lined up in a single row, one under the other. If they're, well, dielectrics, those are in a separate category altogether. In fact, dielectrics turned out to be gases. That is, in general, if you arrange them by density, from less dense to more dense, that's how it turns out. And if these are materials that have so-called magnetic properties, they all line up one under the other. He didn't arrange them like that on purpose. They line up that way automatically. If they are conductors, they all stand in a single row. Conductors? How is that a miracle? It's not a miracle at all. And when he did this, he ended up with 4 types of helium. But at that time, only 3 types of helium were known. Yes, well, supposedly maybe there was a 4th helium, but after lunar soil was brought back, it was precisely the 4th helium that was discovered there. In lunar soil, helium-4. And mathematically, it was predicted before that.
This is how it works. Thank you for everything, mathematicians.
Thanks for everything. Yes, mathematicians. Well, it turns out that Rybnikov has both a 0 series and a 0 period, just like Mendeleev. It was. That is, there is a particle that everyone is looking for, a particle of God. This is the one that gives mass to matter. This is the electric charge. It is electrically neutral. It has the shape of a sphere, because in nature, everything tends toward a sphere. We can check this by inflating, say, a soap bubble, right? It doesn't come out as a square. And in general, everything in nature tends to take the shape of a sphere. If, for example, no matter what natural things we look at, everything is like that. Even if people eat a lot, they also tend to
take on a spherical shape. Yes.
That's absolutely right.
You mentioned a particle called the God particle. Well, in science it's more commonly known as the Higgs boson. Could you please tell our viewers a bit more about it? You can use simple words or scientific terms. It's very interesting.
I can explain it in very simple terms. So this particular God particle, it's not exactly that the Higgs boson is truly the God particle. There was a scientist, let's say, supposedly there was this very influential physicist, Peter Higgs, who is credited with discovering this fundamental particle. A particle that consists of 3 more quarks inside. These quarks had some specific names. I'm explaining in a very simple way why it's called the Higgs boson. If we take the surname Higgs and write it in Russian, just write Higgs, we end up with just the letter H. If you are able to successfully display this particular inscription right here, yes, the word Higgs, we just simply get the single letter H. This is a very interesting and unique observation to make. It was the H particle. And I think there was never any scientist named Higgs who supposedly discovered this particle, which was further divided into 3 quarks that had some names, and then there was also the Higgs-GGS. 222. There was also the GGS, who supposedly discovered something quite significant as well. They found some kind of fundamental particles, perhaps bosons or dudons, as they had some rather interesting names like that. Yeah, it doesn't even really matter that much anymore, fundamentally speaking. The thing is, we can't even verify any of this, not at all. They can say whatever they want, really just anything, without backing it up with anything, so to speak. And then, for example, when you come to some organization and the people working there start telling you, but look, they've found it, they've proven it, and you just think, come on, where are you getting this from? It's all just some kind of theoretical speculation, really. Well, here they are, this collider, the Hadron Collider, they really are looking for something there, you know, this so-called God particle. But to find it, you could have just rubbed 2 objects together, and that's it. Actually, everything is really in this friction. And from studying this process of friction, by the way, even before Rybnikov, Dubinin was working on this issue, and he was also seen a bit differently in that regard. So how did that happen? He couldn't understand where the charge comes from. In other words, he didn't have the same question as Rybnikov, whether it's static or dynamic, but rather, where did it actually come from? It turns out that if we grind 2 pieces, say of metal, yes, metal pieces, if we grind them into powder, and they somehow disappear, this is what's called invisible wear.
Yes.
Mechanics say, well, it went somewhere, it completely disappeared somewhere, it's quite unclear, but if we connect some electrical device into this particular circuit that clearly shows us the presence of electricity, we'll readily see that an electric current is indeed flowing, a direct current, in fact, a constant and unwavering flow, and throughout this entire process, as long as we diligently keep grinding the 2 pieces together, we'll only ever get a direct and continuous electric current. At the very same time, the substance itself doesn't noticeably increase, so where exactly did it ultimately go? It ultimately transformed into a direct and continuous electric current, which profoundly signifies that all substances, indeed, he meticulously rubbed all substances, are fundamentally composed of inherent electric charges, because we exclusively obtained a direct and uninterrupted electric current.
And in addition,
the formula is simple. The work done in moving is equal to the work of charge release. When you move one surface over another, you do 2 types of work. The work of movement, which mechanics like, and the work of charge release.
And
these 2 components were separated. One was given to the mechanics, the other to the physicists. That's it.
But
it's actually one process, it's a single process, you can't separate them from each other. And this is where their confusion arises. No one knows what wear is, there are no definitions. What electricity is, there is no definition.
Because they separated what was actually part of a single whole, and only together can it provide a complete picture. But if you combine them, the work done in moving is equal to the work of charge output. Then you start to get a complete, a whole and comprehensive picture. Yes, a profound understanding of the world in general. If we assume that all substances are fundamentally made up of electric charges, and that the charge is electrically neutral, and well, for example, our very own table, yes, it also consists of electric charges, it possesses a certain density, and if we consider only density as the primary basis, then these electric charges, following the principle of a nesting doll, compress deeply into each other, sort of interpenetrate, yes. So, 2 charges, they inherently have, well, 2 distinct fields, and a third emergent field forms between them, and that's precisely how substances are constructed under specific conditions. Under some particular conditions, you might get gold, under other different conditions, you get iron, under still other conditions, you get something else entirely. So there needs to be a certain precise... So what remains is to determine the specific conditions for each substance. Yes, specifically for each one.
Of the various substances, and indeed, we can readily create these particular substances, well, if we truly and genuinely want to, that is.
Sounds logical.
Well, yes, and basically they compress into each other, forming a solid, unified substance. To separate them, you absolutely need to rub them vigorously, and that process inherently produces an electric current. And an electric current is generated exclusively by friction, nothing else at all. There are no other fundamental processes involved. Everyone immediately talks about solar panels, but with solar panels, there's no actual friction. There, you're simply collecting ready-made pre-existing electric charges. That's essentially it. It's just the sun's direct influence, nothing more complicated. You're simply gathering the electrical charges that are already present and available. For everything else, you invariably have to spin a turbine, either with the powerful force of water at a hydroelectric power station or with superheated steam at a nuclear power plant. But you're always rotating something substantial, and there's always friction involved, no matter how you meticulously look at it or analyze the process.
No matter how much we try to get away from it, friction always remains here.
That's what everyone universally says about the brilliant inventor Nikola Tesla, who essentially profoundly transitioned humanity from the established direct current system to the more efficient and widely adopted alternating current. But what exactly is this alternating current? It's often described as a broken current. It's not truly alternating in the way many people might imagine, where the electrical poles supposedly switch their positions. In actual reality, nothing fundamentally changes. It's simply being interrupted precisely 50 times per second or 50 hertz, right? Perhaps you've heard in the standard wall socket, it's typically 220 volts and 50 hertz. Those two fundamental scientific principles live there and diligently work to make electricity readily available for us. So, this electrical current is just being interrupted at a consistent and rapid rate of 50 times every single second. Why is this particular method of interruption done? It's primarily done so that we can efficiently transmit this electrical energy over very long distances without significant loss.
Is it possible to amplify this signal somewhere with transistors?
Well, it comes to the substation and there's a large and powerful transformer there. It meticulously transforms the electrical current for you, right? There's even a well-known and amusing joke about precisely how a transformer fundamentally works. Just like that, that's exactly what a transformer effectively does. Basically, that's precisely what it accomplishes, and that's a truly monumental achievement attributed to the brilliant Nikola Tesla. Thanks to his extraordinary ingenuity and tireless efforts, it became entirely possible to successfully create a sophisticated and highly efficient centralized electricity network, which, in actual fact, is what the entirety of humanity extensively uses and relies upon today. Consequently, modern cities rapidly appeared and flourished, and people, well, they actually became, in a sense, hostages to this pervasive and indispensable system, because electricity isn't given for free, and it turns out that electricity is without a doubt the most crucial and fundamental resource on the entire planet. Without it, absolutely nothing truly works or functions as intended. Let me provide you with a concrete and illustrative example. Before I had the opportunity to meet Rybnikov, I diligently worked as the director of a housing and utilities company, and everyone consistently paid for water, paid for electricity, paid for garbage removal, and so on and so forth. But in reality, everyone was primarily paying for electricity, your pump that diligently pumps water. Oh.
Electricity?
It runs entirely on electricity, and it also supplies water. Essentially, the individuals who arrive to make payments for the water are in actual fact not paying for the water itself, but rather for the electrical power. This is because the water is fundamentally free in that particular location. It simply gets pumped from its source, and that is the entire process. It is solely for the operation of the pumping mechanism, is it not? Subsequently, the financial resources, these essential utility payments, are directed towards our electric company, not for the water provision, but specifically for the electricity consumption. Do you comprehend? And fundamentally, all of the modern amenities and conveniences that we currently possess are powered by electricity, are they not? If we were to completely disconnect the electrical supply right now, that would be the definitive end. We would instantly revert back to a primitive existence akin to the Stone Age. There you go. So, this is indeed the power station, this particular model here. Yes, our very own power station. One of its primary and most profoundly significant purposes is to empower individuals by providing them with their own independent and reliable source of electrical energy, thereby allowing them to be considerably less dependent on, let's say, the traditional utility sellers or other external providers. This electricity.
Right, yes, I actually wanted to comprehensively wrap up this particular topic by talking about the fundamental fact that there is a widely familiar understanding of energy, a very common and familiar understanding of electricity, and let's say its inherently limited availability. You just mentioned the urban environment being intrinsically tied to some kind of central hub or facility, but what exactly does having a powerful generator like this, approximately the substantial size of a shipping container, actually provide or give to an individual person?
It's actually very simple, even just to deeply consider it yourself. This particular question feels a bit strange to me, personally. Perhaps it's because I was born and raised in a village, a rural setting, and for me, I've always fundamentally thought if I had my very own independent source of electrical energy, then that would truly be it. I would essentially have everything I could possibly need right there. I could then develop some kind of productive business venture, for example, anything at all that fundamentally runs on electricity, say a powerful jigsaw or a precise milling machine, or perhaps some other advanced technological equipment. If I had access to completely free electricity, I could meticulously make various parts, right, intricate parts as a finished product, and I could then sell them at a significantly cheaper price because there would be absolutely no electricity costs to factor in. That's one incredibly significant advantage. Then, for instance, I could hang bright, illuminating lights all over my entire yard, making it much brighter and more secure for me during the evenings. I wouldn't have to pay the power plant, I wouldn't have to pay for heating, because in the end, if we're burning firewood, for example, if we possess our own self-sufficient energy source, we could simply plug in an electric heater or efficiently heat the entire place that way. Or there are numerous other viable options like effectively circulating warm heat throughout the entire house or heating water in a large insulated storage tank. There are truly lots and lots of practical options available. Then, for example, the very same principle applies to water supply, whether it's hot or cold water. Please consider all the essential appliances within the house that consistently run on electricity, the refrigerator that operates non-stop, the computer, the television, basically all the modern household appliances. That would just be absolutely wonderful, right? I would have my own reliable source of electricity and a deep well for water. So I would have both readily available hot and cold water, and I wouldn't have to pay any extra for anything at all. That's truly awesome, genuinely awesome. Even just that much alone would be a tremendous benefit.
You could call it independence.
Yes, indeed, independence. And this particular power station can fully and completely supply a typical house, specifically 16 kilowatts of power. Really, anyone with a bit of thought can just sit down, thoroughly think it through, and easily understand everything about it. Well then, more...
Thank you very much for a fascinating and popular science discussion. Dear friends, follow us on social media, leave your comments, ask questions. We will, of course, do our best to answer them, and we look forward to seeing you in the next episode. Viktor, thank you so much for such an engaging conversation.
Thank you, Alexander. Thank you for having me. I will certainly be waiting for your next invitation, and if there are any questions or inquiries, I will be more than happy to provide answers and assist you further.
We'll be getting ready.
Yes, thank you. Goodbye. Goodbye. Goodbye.